First, let's create a new module, just like we discussed in the last video. We'll name this module Core UI and then update the package name to match. Once that's done, hit Finish and sync the project to apply the changes. Next, we'll quickly add the required dependencies, and don't forget to update the versions in our libs.versions.toml file. You can find all the dependencies in the GitHub project, linked in the description below. Now, we're using API instead of implementation for some of our dependencies. The key difference here is that API exposes the dependency to any other modules that rely on this one. This means those modules can use the dependency as if they declared it themselves. However, a downside of using API is that it can sometimes slow down build times. On the other hand, implementation encapsulates internal libraries, which improves build times, but it hides the dependency from other modules. It's important to choose the right approach based on your project's needs. Let's break down our UI into manageable components. We'll create these components step by step, and you can see the composable names on the screen. Take a moment to pause the video and review the structure before moving forward. First, let's see what is meant by column, row, and modifier in Jetpack Compose. Imagine you have a surface which is shown as light pink. Columns help us in organizing items vertically on the screen, which is represented by the sea green color here. And finally, the yellow section, which helps to lay the views in the horizontal manner, is called rows. Modifiers allow us to decorate or change a composable behavior or appearance. So let's say we need the row to have a gray background and rounded corners, then we use modifiers. We'll be creating all of these composables inside a package named Component under the Core UI module. Let's go ahead and start building them one by one. We will start with Circular Profile Image. We will use Glide Image from the Glide Compose library, and using modifiers provide the shape and clip as circle shape and use the content scale as crop. We will also assign a default size of 32 dp. Next, we'll create our home app bar. We'll start with a row, giving it a rounded corner shape and aligning the content center vertically. Inside the row, we'll place a menu icon button, the search text, and the circular profile image that we just created. For now, we'll use a dummy image source for the profile image. Once that's set, let's run the preview and see how it looks. Before we move on, let's add the extended material icon dependency, which I missed earlier. We'll need this shortly, so it's good to have it in place now. Next, we'll create our details app bar. Just like before, we'll start with a row, align center vertically. Inside, we'll add buttons for back, archive, delete, new mail, and more options. If needed, we can use multiple at preview annotations to see different variations of our UI. Let's also add the dependency for the nav controller and check out our preview. The linear full screen progress will be a simple one. We'll use a column, align it to the center of the screen, and add a linear progress indicator to display the loading state. Next, we'll create our full screen error component. This will take two inputs, an error message and an icon to display. We'll use a column, center the content like we did before, and apply material theme typography with title large for the text styling. For the email item, we'll be using constraint layout. First, we'll define the input parameters for the function. Next, we'll set up constraint layout as our top-level view, using the full width available. We'll also create the necessary references for our views. We'll check if the profile image URL is non-null. If it is, we'll display the profile image aligned to the parent top and start. If the image is null, we'll display the initials from the sender's name inside a circular shape. Next, we'll add the sender name text, positioned relative to the profile image with a 16 dp margin. It will fill the available width until the start of our time reference. For the email subject, we'll place it below the sender's name, also taking up the full width until the star icon reference. Finally, the date will be positioned at the top right corner, aligned to the end of the sender's name. Let's quickly check out how this looks in the preview. Next, we'll work on the email details sender info component. We'll use the isPromotional field to determine the behavior of the button at the end. If isPromotional is true, we'll display an unsubscribe button with a menu. Otherwise, we'll show a mood icon and a shortcut icon. Finally, at the end of the row, we'll add a vertical more menu icon to complete the layout. We'll apply a similar Boolean value to control the behavior of the email bottom section. First, we'll always display the attachment icon. Then, we'll create a row with a rounded corner shape, and based on the reply mode, we'll conditionally show either a reply bar with input or a simple reply bar. First, in the reply bar with input, we use a row to align elements vertically centered, and inside, we add icon buttons for shortcuts and drop-downs. We then display a text field for the user to type a reply with a transparent background. In the reply bar, we follow a similar structure. Instead of an input field, we display the text reply and add a few icons for user interaction. Both components use auto-mirrored icons, meaning they adjust direction based on layout direction for better localization. For the email detail subject, we'll take two inputs, the subject and the tag. We'll leverage an external library to build an extended annotated string that allows us to style the tag text with a rounded background. Now that we've finished building our components, let's create an extension function to extract the initials from the sender's name, in case the profile image URL is null. Next, we'll create a helper function to format the date into a more readable format. We'll use simple date format for this. First, we'll parse the original date string using its input format, and then we'll reformat it to the desired output format, making the date much easier to understand for the user. Make sure to import the necessary libraries for date formatting, and we can easily reuse this function across our project whenever we need to format a date. Before we create our MVI contract, let's take a moment to understand its key concepts. In MVI, Model View Intent, Architecture, the core concepts are state, event, and effect, which together help manage the UI in a predictable and consistent way. State represents the current UI shown to the user at any given time. For instance, in an LCE, loading, content, error, pattern, only one of these states can be visible to the user at a time. This ensures the user sees a clear, well-defined state of the app without confusion. Effects are one-time actions that the UI performs, such as navigating between screens or showing a snack bar. These don't change the UI state directly and are typically actions that are not to be retained across configuration changes, like device rotation or screen resizing. Events are the user interactions with the UI, such as button clicks or gestures. These are sent to the view model, where they are processed and transformed into either a new UI state or trigger an effect. Jumping back into the code, we'll start by creating an interface contract for our state, effect, and event. This will help us define the structure of our MVI components and ensure consistency across our implementation. Next, we'll create a separate interface specifically for our event, where we can define a function called event to handle the various user interactions. We'll also set up our state flow and shared flow to manage state updates and one-time effects like navigation or showing a snack bar. We'll see these in action shortly as we integrate them with our view model and UI component. Let me quickly adjust a few dependencies for the presentation module. If you run into any issues or get stuck, feel free to check out the GitHub repository. The link is in the description. Now, let's move to the feature package that we defined in the last video and create a new file called email list contract inside the MVI package. First, we'll create a sealed class for our event. This will handle two actions. 1. Loading the email list. 2. Handling the user action when they click on an email item. Next, we'll explore two different styles of creating a UI state. For the email list screen, we'll use a sealed class, while for the detail screen, we'll use a data class. This way, you can get a feel for both approaches and how they can be applied. For the email list screen, we have three major states: loading, success, and error. Lastly, we'll create a sealed class for our effects, which will handle navigation and pass the email list model to the next screen. To wrap it all up, we'll place our state, effect, and event classes inside an interface and extend the MVI contract that we just created earlier. Now that we've completed the major work, let's quickly add the view model. We'll annotate it with the rate Hilt view model, and in the constructor, we'll inject the email list use case that we created in the last video. Next, we'll implement the email list contract we just created and override its members. Let's create a helper reducer function that takes in the current list state and updates the mutable UI state accordingly. In the event block, we'll handle the two events we created earlier. For email clicked, we'll emit the effect to trigger navigation. For load email list, we'll call our use case. You'll notice we use the fold function, which we implemented as an extension to our either class in the last video. On the right side, we'll display our email list, and if there's an error, we'll show the error state on the left. Let's integrate our view model with the list screen. We'll start by collecting the state from the view model and using a dispatch function to trigger the appropriate event. For navigation, we'll use launched effect to handle one-time actions, such as moving between screens. We'll also load the email list here. However, note that launched effect won't survive configuration changes, which is not ideal. We'll address how to fix this at the end of the video. Next, we'll add the UI components based on our UI state. For the email list UI, we'll use a lazy column to display the list of emails. It's good practice to use a key for each item to avoid unnecessary recomposition. You could also annotate the model class with that immutable to ensure it remains unchanged during recomposition. For each email item, we'll use our email item composable to show the list of emails in the UI. We'll follow the same steps for our detail screen. The main difference here is that instead of using a sealed class, we'll use a data class for our UI state. This allows us to more easily represent a structured view of the UI with different data points. There will be several events for this screen, but for simplicity, we'll implement only a few key ones. The rest can be added later as part of your practice. Adding the email details view model is straightforward at this point, but just to reiterate the steps, we'll need to use the @Hilt view model annotation, inject the use case, and implement the interface for the contract. We'll then override the necessary member variables and functions. Next, we'll handle all the events for this screen. Finally, we'll quickly call our use case in the load email details method and update the UI state based on the result. And finally, we'll complete the implementation of our email detail screen. We'll use an if condition to check for the loading, error, and valid UI state when our model is not null, ensuring we handle each state appropriately. With most of our components ready, I'll update the implementation for our email details UI. In this case, we're using an Android view to display the web view for rendering the HTML body that's returned as part of the response. You can also use Android View and Jetpack Compose for other components, such as maps or any native Android views. I'll quickly do some refactoring by moving the UI theme from our app module to the core UI module. This will help centralize our styling and keep the structure clean and modular. Finally, it's time to tie up all the loose ends so we can see our application in action. First, we'll open our main activity and remove the default implementation. We'll be using type-safe navigation, which is available in Navigation 2.8.0. To make this work with Jetpack Compose, we need to define a serializable email list object and a serializable email details data class for our details screen, which will also help in sending the arguments. Next, in our main activity, we'll define the nav controller and we'll create an enum for our top app bar with two values, home and details. We'll use a scaffold, which allows us to structure different parts of the UI, such as the top app bar, bottom app bar, and the main content. Depending on the app bar state, we can either show the home search bar or the details app bar. After that, we'll add our main content. We'll create a nav host and set the start destination as our email list screen. Inside the nav host, we'll add a composable for the email list screen, define the app bar state as home, and pass the onClick lambda for handling item clicks. Next, we'll add another composable for the email details screen, retrieve the argument pass from the email list screen, and forward it to the details screen for rendering the selected email. Let's clean things up by moving the top app bar state to its own file for better organization. To get the app running, there are still a few minor things we need to resolve. First, we'll need to create an app class that extends application and annotate it with Hilt Android app. We also need to do the same for our main activity by adding the @Android entry point annotation. Finally, don't forget to add the app name in the Android manifest file and ensure you have the internet permission included so the app can access network resources. When we run the app, we're seeing a 404 error. Let's check the logcat. The fix is simple. We mistyped our endpoint in part 1. We accidentally named the endpoint email list instead of email in our API service class. Let's quickly fix that in the API service class and rerun the project. At this stage, we have our app up and running, but there are a few issues we need to address. 1. Padding between the email items isn't looking great. 2. The dates are in the wrong format and order. 3. There's a noticeable lag when transitioning between the email list and detail screens, which impacts the user experience. 4. Our status bar icons are not visible in the edge-to-edge display. 5. The screen transitions are not smooth, making the app feel less polished. Let's go ahead and fix these issues one by one. Fixing the padding is fairly straightforward. All we need to do is provide the appropriate padding between the email items. To fix the date format, remember we created an extension function earlier. Let's make use of it here. This will format the dates correctly. To fix the order of the emails, we'll go back to our email list mapper and sort the list accordingly. Now the email list looks much better. Before we move on to optimizing the details screen, let's add our app icon. I'll export the Gmail icon as an SVG and save it as Gmail app icon on my system. Using the image asset tool, we'll create an adaptive icon for our app. Simply import the icon, adjust the scaling to ensure it fits within the safe area, and change the background color as needed. Once everything looks good, click Finish to generate the app icon. On the next run, you'll notice that our splash screen now features our logo instead of the default one. This gives our app a more polished and branded look right from the start. To fix the edge-to-edge status bar issue, let's open the theme.kt file. First, we'll get a reference to the current view and check if it's not in edit mode. Then, inside the side effect block, we'll assign the status bar color to the surface color using .targ. Finally, we'll set the inset controller to ensure that the status bar icons are visible by disabling dark mode for the status bar. To fix the transition animations between screens, we'll add exit and pop enter transitions for smoother navigation. We'll apply this to both screens. As our app grows, we can clean this up later to avoid repeating this code for every composable. Before running the app again, let's optimize our web view. We'll load the web content first, so we don't experience any lag when the web view is displayed. To do this, we'll use a mutable state of Boolean to track if the content is fully loaded. If the web view is still loading, we'll display a circular progress indicator. Once the content is loaded, we'll hide the progress indicator and show the web view. Now that we've achieved smooth transitions between screens and the web view is loading seamlessly, let's move on to implementing our bottom bar. We'll use the built-in bottom app bar composable and place a row inside it, arranging the items with space evenly. The bottom bar will include 2 buttons, email and video call. Now, let's learn how to add the drawer navigation menu to our app. First, we'll go back to our core UI module and create the different components needed for the drawer. We'll start by adding the title. For each of these components, we'll follow the material design guidelines to ensure consistency and proper styling, providing a smooth and user-friendly navigation experience. We'll include the link to the material design specs in the description below, and I encourage you to try creating the other components as per your need on your own as an exercise. The final solution, following all the proper guidelines, will be available in the GitHub repository at the end of this video series. We now have all our components, so let's create a sealed class called DrawerData. This sealed class will contain a title category, an item data class, and a divider object class for separating sections. Next, we'll create a file called DrawerItemContentProvider, where we'll define a function that returns a list of DrawerData objects. Using a sealed class gives us the flexibility to add different types of views in our lazy column by checking the type. This approach is very similar to how we used to handle different types of views in a recycler view, where multiple view types are shown in the same list. Many modern apps implement a content solution that provides this list dynamically without requiring app updates. However, implementing this also requires a deep link management architecture to handle dynamic destinations that might be provided as part of the content items action. First, let's head to our home app bar and include a Lambda function as a parameter in our composable, which will invoke when the menu icon button is clicked. There could be 3 possible states for the drawer: open and close. These states will need to be updated within a scope, so let's add those states and define our drawer state with an initial value. Next, we'll define the drawer content by creating a new composable. This will include a lazy column. In fact, we can simplify things by removing the top-level column and directly using the lazy column as our top view. Based on the type of drawer data, we'll call the appropriate components for each drawer item. Let's run the app and see how it looks. Now let's move toward the second last part of this video and add our drop-down menu. By the way, if you're enjoying the video so far, don't forget to hit the subscribe button and like the video to stay updated with more content. We'll start by creating a data class and a content provider, just like we did for the drawer menu. Next, we'll head to our Details app bar and define a few mutable states to track whether the drop-down menu is expanded. To display the menu properly, we also need to calculate the offset of the view. We'll handle this by doing some calculations to find the position of the icon. Let's run the app again and see the menu option. To address the issue of launched effect not surviving configuration changes and causing repeated API calls, we'll create a generic extension function for Flow to manage state more effectively during active lifecycle states. Step 1. Create the extension function stateInWhileActive. In our core UI module, this function will take in a coroutine scope to manage the lifecycle, an initial value to provide the default state before any data is loaded, a prefetch Lambda function, which in this case will be used to load our email list via the API. This extension function will help ensure that the state remains active only when the screen is active, avoiding unnecessary API calls when the configuration changes. Step 2. Update email list viewModel. Next, we'll modify the state flow in our email list viewModel to use this new stateInWhileActive extension function. Step 3. Remove launched effect in the composable. Since the viewModel now handles data loading and retains the state during configuration changes, we can safely remove the launched effect from the email list screen composable. That's it for this part of the series. In the next video, we'll start adding test cases for our viewModel, domain, and data layer using Mach-K. Thanks for watching. Don't forget to subscribe to the channel and like this video. And make sure to hit the notification bell to get updates for the next video.